Good morning. Good morning. For those who don't know me, my name is Blair Fraser. I am trying to lead us through the next generation of ultrasound. I'm here with Scott, who's going to be our director of go-to-market. We're going to walk you through the evolution and changes of ultrasound. Before we do that, I just want to reflect on three simple words. I do UE. You're going to see it throughout the hallway. 6 years ago, when I started at UE Systems, I started to hear something that very few brands, very few companies have. The technical word is genericization. You might know it from Band-Aid, Kleenex, Xerox, words like that, or companies like that, right? Is the brand is associated with what they do. So when I started 6 years ago and I started to talk to our customers, it was very interesting, and very quickly I got to clue into these three words. Because when I asked customers what type of predictive technologies they use, they would say, I use vibration, and then they would say the company name of the vibration analyzer. They would say, I do oil analysis, and they would tell me the name of the oil analysis company they do. They would say, I do thermography, and most often they would say, I do FLIR. But when it came to ultrasound, they never said, I do ultrasound, and I use UE equipment. It was always, I do UE. In fact, it was so ingrained into the culture of ultrasound that it made it to work order systems. It wasn't doing ultrasound routes, it was doing UE routes. It was doing UE inspection. And that's when we knew how important these three words are. I do UE. And it is our job as this company to represent this brand to make sure tomorrow, 10 years from now, another 54 years from now, that you are still saying, I do UE. So with that, we believe that sound carries meaning. We're an ultrasound company. So every little bit of sound coming from our equipment, whether it's a motor, a gearbox, it doesn't matter, that sound carries meaning. What we need to do is know that hearing is not understanding. We do not need to hear more. The world is full of noise. If we just echo that noise, we're going to have less and less understanding. We need to listen better. We don't need to hear more. We can hear plenty. We need to listen better. We also have to understand that just understanding what happens is not action. We're not changing anything just by knowing. We need to get to the do. We need to get to that next step. And that's why these products that we're releasing and this software is around getting closer to the meaning. So let's just give a little history. We first started off by listening. We created products that allowed us with our ears to hear what we couldn't hear as humans. We simply created listening devices. We could listen to inside of equipment that we couldn't hear normally. We evolved, and we started to measure. We started to create products that could then historize or trend or capture data that we could then trend over time. This was really the forte into reliability. We could start to trend a decibel over time. It seems simple, and we were limited back in the day to 400 values, 400 decibel storage that we could keep, right? But we turned sound into something that we could trend. And then magic started to happen. We realized that we could analyze. The same techniques that were happening in the vibration world, we could also apply to ultrasound, right? We could flip a time waveform, or some people call it an audio signal, on different axes and look at a spectrum or an FFT. We started to analyze that data in software. And then, most recently, we automated. We automated the action part with autonomous condition-based lubrication. We created a brand new category that never existed before, which was autonomous condition-based lubrication. We took the listening, the analyzing, the measuring, and the act all into one. So no longer do we have to manually go out and lubricate our bearings based on condition. That was a huge milestone for UE Systems. And that brings us in to the next generation of where we're going next. And this is the area where we are bringing intelligence. Intelligence into our devices, and intelligence into our systems and our workflow that powers ultrasound analysis.
So for this next chapter at UE Systems, we look forward to coming on this journey with you. And as we go on this journey, I remember a time in my career where I was headed on my first international business trip, and I was headed to Beijing. Now, my colleagues recognized I had zero command of Mandarin, I had zero command of Chinese culture, and they said, no worries. If you can capture this simple phrase, you'll have all you need to navigate China in transit and in restaurants and at work. And I said, fantastic, what is this? Anybody here can read Mandarin? Okay, you got one? Can you read this for me? Very good. Okay, my poor pronunciation is Ting Budong. Now, I think enunciation matters quite a bit. I'm not sure I've nailed it. But the phrase means to hear, but not understand. Now, I've unfortunately shared this with my wife and kids, so when I tell my kids to go make their beds, you know what they tell me? Ting Budong. I hear you, but I don't understand. Now, why is this helpful in culture, right? I thought, okay, if somebody says something to me and I reply with, I hear you, but I don't understand, what happens next? Don't we just shut down and say, sorry, like it's not going to work? So I tried it. I flew into Beijing, got on the subway, jet lagged, unsure of the sounds I heard, the smells I smelt, or the place that I was. I was in the subway, standing right in front of the subway door. It was the most American thing I could have done. And somebody needed to get out, and they said something to me, which I expect was probably, please get out of my way. And I said the only thing that I knew to say in Mandarin, Ting Budong. And what happened was, the lady who said this to me says, either she had to understand that I didn't speak Mandarin, so she could switch to a language we might have in common, or we could play charades. She chose the latter. We played charades. She gestured that I needed to slide over. I understood that I needed to slide over, and she got the action that she wanted to communicate, all because of Ting Budong. What does this matter to maintenance and reliability practices, to ultrasound? The phrase Ting Budong encourages us to re-articulate the meaning in order to get the action that we wish for. And at UE Systems, we have re-articulated the meaning and the value in order to drive the right solution to the right problem for you using a methodology of detecting, diagnosing, and acting. Nothing super exciting here in terms of the actual words themselves, but think about the practice. Detecting, this used to be the hard part, right? We had sounds, we had data, we had all of these things that were quite difficult to collect. Now in the industry, this is table stakes, right? We don't have a problem generally about collecting data. Maybe we need help optimizing routes, maybe we need help putting sensors on things, but at the end of the day, the data is accessible to us. We have matured in that category. Now, we still will bring to market tools that will enable us to collect data, to make inaudible sounds audible, and we're quite good at that. But the real opportunity now is to make sense of all of this data. Once you have the data, we've more or less checked that box. What do we do with it? I think you probably ask these types of questions every day of, I had a machine fail, I had data on it, how do I use that data and interpret it to give me the symptoms and side effects that I know will indicate this type of failure so that I can intervene? That diagnostic option is the lens by which we view our solutions. We can detect things, how we can interpret those things into meaning, and then finally, most importantly, how do we act on them? All of these detecting and diagnosing are just means to an end, right? If I knew exactly what to do with the right parts and the right insight, but never did anything about it, I would have never gained anything. And so we're bringing to market products that actually autonomously intervene as we get the data, know what to do with it, and can actually implement the change. So what does this look like in practice? Let me encourage you to use this methodology with us, right? If I throw up a couple of common problems that you may experience in your organization, and we pair those with applications that we know ultrasound is really competent in solving for, and then think, what is the outcome that I want to deliver with that solution? We can have a choose-your-own adventure of reliability and maintenance best practices here. So let's play, shall we? If you tell me I have a problem with premature equipment failure, my PM compliance isn't looking very good, and that's probably a symptom of I just don't have the people. Okay, well, what does that mean as far as your applications are concerned? Well, I'm having machine failures because bearings going bad, and I recognize that I have a poor lubrication practice that probably leads to that. We heard yesterday, if you were part of the master class, that inadequate lubrication accounts for the lion's share of premature bearing failure, machine failure. Okay, so if that's the case, what do you need? Do you need something to just detect? Do you need to capture data so you know this is a problem? Probably not. In this case, you know it's a problem. You have the downtime. Do you need the diagnostic evidence? Do you want me to tell you it's inner race, outer race, what kind of symptoms are going on? Maybe that would be helpful so you would know what to do. But at the end of the day, you just know you either need to lubricate well or in the worst case, replace the bearing. So maybe the solution that you need is more of an ACT kind of solution. And so there we would now look at our product portfolio and say, okay, if I were to look at our suite of products, how do I stitch together something that gives you exactly what you need? If you gave me all of those variables, I would point you to OnTrack. It will autonomously collect the data, autonomously diagnose, and most importantly, autonomously intervene. So as we look to this next stage, the next 53 years of UE, we're looking at it through this lens. How can we help you detect the data that you need to make the right diagnostic decisions in order to initiate the right kind of action, so that when you hear your equipment speak, you don't say to it, like my kids say to me, everybody say it, ting bu dong. So if you don't get anything out of this presentation, take this home to your family and see if it doesn't work in practice. Let's double click into each of these areas to identify what innovation that we can bring, starting with our detect solutions.
Thank you, Scott. Tim Bu Dong. And we go behind the scenes. I have sent Scott emails and I get 3 words back. Tim Bu Dong. In fact, it may have happened last night as we were prepping for this. And it became unfunny at some point. So we're bringing intelligence back into this product portfolio of detect, diagnose, and act. And I think it's very humbling that we stand on this stage at Ultrasound World in Clearwater, Florida. I want to acknowledge the fact that we have been doing Ultrasound World since 2005, which I incorrectly did the math because I didn't believe it was that long and said it's 11 years. But if you do the math correctly, it's 21 years Ultrasound World has existed. Some of you might have been here for the very first one. Just heard recently, milestones have been created at this event in this stage in Clearwater, Florida, that has set the trajectory of UE systems. And today, after the hard work of many people in this room, but many of them are back behind the scenes, creating these products, creating the vision of to change the way we listen to machines is going to come out today. So let's focus on detect. Detect in my world is binary. Is there a problem or is there not? right? As you look at your critical assets or just your assets in general, sometimes you don't need to know, is it an erase, is it an erase? Just tell me when something's wrong, and I'm gonna go start another one, replace it, or do something. Detect can become a very important strategy in your reliability, your condition monitoring program. So detect is going to get intelligent. So as we look at our portfolio, is normal isn't always fixed. If you look at how we have shoehorned ultrasound into applications, it's because it's repeatable, it's reliable, and we can set limits to it. Many of you have equipment that doesn't operate. We get calls all the time. I have this one piece of equipment. It's been Frankenstein together. It's one of a kind. There's no manual for it. Only person that knows how to work is Bob, right? And Bob's retiring. So how can ultrasound help me with this piece of equipment? Oh, by the way, it starts and stops randomly, and it lifts 50,000 tons into the air. But other than that, can you help me solve my problem, right? So what do we do in a world that isn't normally fixed? Where fixed thresholds don't always tell the story. We can't set a single threshold that operates every failure mode of that piece of equipment. Chances are you experiment on your own. You try to solve that on your own. So what if we have a system that learns what normal is, no matter how variable, how crazy your piece of equipment operates? But it can tell you through all of its operations, through all of its movements, through all of its seasons, through all the pain that you put it through, it can tell you what normal is. Normal is not necessarily good, it's just the way that it's operating now. So it can detect abnormal change. This is the heart of detect. And I fully believe as we move to an age of intelligence, on these critical pieces of equipment, just telling you something is abnormal. Something is happening inside of that machine or around that machine from an ultrasound point of view, that something is off. I can't tell you what it is yet because I don't have enough data, but something is off. And that machine is so critical, you need to go with all your collective toolbox of ideas and equipment and go inspect it a little bit further. This is about prioritization. This is about those assets that you might have scaled across your facilities, your plants, your sites, that you just don't have the resource to go listen to. We've had a customer tell us that they have to go into their facility every morning and they just do a listening route. They just hear with the ears. Do you hear anything abnormal? Right? Can you imagine doing that every morning? Did you hear anything funny? Did you hear anything click? Right? And I can tell you, this company, your kids or you yourself might be riding their equipment. Right? But that's the only thing they can do, is they rely on human expertise to say, something's a little off, something didn't sound right. So what if we were to automate that? Introducing pattern intelligence. It is a machine learning program to ingest your ultrasound data over time and learn what is normal. And more importantly, tell you when it becomes abnormal. So it's designed to plot an anomaly score. Anomaly score is based on many machine learning models that combine into one score to tell you how anomalous, help me out here, anomalous, thank you, is that asset or that data coming from that asset today. This is a real life example of a linear actuator, right? You can start to see one started to peak up. Out of a fleet of 32 actuators, there is tremendous value in saying, hey, this one is acting different, not only from itself. So the power comes when you can compare it to not only itself in its past history, but also its peers. If you have like for like, pattern intelligence becomes even stronger because instead of learning off of one, we can learn off of many. And we can compare them. Hey, did you hear that? You didn't. You're the only one that heard it. It must be you, right? So we can start to know where to look first. We can look at things like outliers. How far out is this anomaly detection? Or degradation. Is this anomaly score starting to degrade over time? And that's the failure we're trying to get. Is acute failures will happen. Things will go bump in the night, things will just stop, right? but what we're looking for is that slow degradation over time, that slow wear and tear. And that's what pattern intelligence is here to do. And it's here to guide you through collectively where to prioritize. So again, looking at priorities, looking at how is it different from its peers? Is it different from itself? Is it both? Is there outliers? Is there degradation starting to happen? Right? And that is pattern intelligence. Our main goal is to learn what's normal in order to detect what is abnormal. I will caution you with this. It is not, there's a bump in that stage. It is not going to tell you it's an inner race, outer race, this, you have 6 days, 3 hours, and 22 minutes before this thing fails. That is the holy grail of intelligence, and you need a lot of data to get there, right? This is simply to sit in our detect portfolio to tell you, am I normal or am I not? So as we move forward, we start to look at diagnose. We start to look at what we can analyze and how we're going to analyze it. Diagnose is becoming intelligent. So with ultrasound, with the innovation that UE Systems has brought, is our data has become richer. We are able to collect more data. We're able to collect more frequency of data. Give you an example, our UltraProbe 15,000 samples data at 44,000 times per second, right? So our data is becoming richer. It's becoming more fidelity of the data. So the data has changed. We need a new way of analyzing this data. A new way to analyze ultrasound. A new way to go beyond just a single FFT. Introducing UE Analyzer, designed to uncover the hidden patterns in your ultrasound data. Allowing you to hear it, allowing you to see it, and allowing you to analyze it. It's purpose-built for ultrasound analysis. And for those that are questioning you, yes, it is designed to replace Spectralizer. It is a modern interface tool that allows us to look at things like auto-diagnostics, a bearing database. So a bearing database where we have up to 88,000 bearings in there where you can plot certain bearing frequencies and things like that. Where if you're new to ultrasound and you need to look at a lot of data, you can simply click a button and it will do its best to identify the top peaks, the top harmonics that are happening in that sound file, right? Just to give you a little edge to know where to start to look at all these squiggly lines. Of course, we're looking at more than just a time waveform. We can look at the FFT, we can look at the spectrum, we can look at an envelope spectrum, we can look at envelope time series data, we can look at autocorrelation data. And for those of you that live in the vibration world, you would know what these are and how powerful they are when they're specifically applied and filtered for ultrasound data. Some of the highlights. Anyone here deal with slow speed bearings? Right, slow speed has always been a challenge. Ultrasound is the #1 technology for slow speed bearings. Often, we tell you don't even look at the dB on your screen, you need to look at the time waveform data. In UE Analyzer, we have a new tool that is called a shock filter. What it does is it filters the data that you capture from your UltraProbe and displays it in a way where it's only showing the shocks or the impact. So now, for slow speed or bearings, mechanical equipment that has impacts, and you want to look at just the impacts, UE Analyzer is going to allow you to do that. And you can see here, before and after, all those spikes were hidden in that time waveform data. Now you can clearly see, is there impacting in my bearing? Another good one is restored clip waveform. So often the data that we capture can be clipped. We lose the peaks, whereas the value, typically in the peaks to the valleys, that transition. Is using AI is we can reconstruct that time waveform to restore those peaks. We use interpolation to do so. In fact, it is so good, it gets up to 99% restoration of a clip time waveform. In some cases, it actually can improve your signal to noise ratio. It will never be as good as not clipping it in the first place. But if you're starting an ultrasound program and new people start to come and clip their data, it's not wasteful anymore. That whole route, that whole data collection can be restored and can be used. Another great feature is it allows us to compare. So with ultrasound, in order to get that sensitivity, in order to get that smallest change to the loudest noise, is we adjust our sensitivity. In order to compare sensitivity or compare ultrasound time and time again, is we need to normalize that sensitivity. If I recorded a value at 60 sensitivity and the next day I recorded at 20, which is an exaggeration, is your amplitudes will be different, your time waveforms will be different. One click of a button, you can normalize them and to standardize all your ultrasound waveforms across the board. So now you can compare them at equal playing grounds. That's UE Analyzer. That's changing the way the world analyzes ultrasound. As we continue that Diagnose thread, and those that were in the lubrication masterclass yesterday got a little sneak peek of what's happening. So when you compare UE or use UE Analyzer, and you start to think about all the data that's now available, is how can one person start to look at all this data and make sense of all that data? Evidence still needs interpretation. You still need people to go through and say that squiggly line, because of that peak in that squiggly line, this is that, right? And if you do a time waveform, an FFT, an envelope spectrum, an autocorrelation, even that's just 4 or 5 squiggly lines you're looking at. And if you have thousands of roots, well, that's 5,000 squiggly lines you're looking at. So evidence is really hard to scale. That's what we see is it isn't the ultrasound equipment that's hard to scale, it's the analysis, it's training people. It's getting them up to that level where they can make good, reliable calls on the ultrasound data that they're seeing. So with that, teams need guidance where the work happens. Often, anyone from UE Systems typically gets calls, hey, can you help look at this sound file is what it's called. What do you think is happening in this? And then we have to go, what's the context, right? What's this from? What did you do? And all that kind of stuff. So what if we were able to automate? What if we were able to use AI in such a way that we could train it so you could simply ask it in UE Analyzer, hey, what do you think? Introducing UE1 Copilot. It is your AI ultrasound assistance built in to UE Analyzer. You can ask it any question about ultrasound. It won't solve your life problems. You can do simple things, and we will have a live demo of this outside, and you can go as deep as you want. We have prompts to guide you through the start. If you just loaded a sound file, you can say, hey, find basic defects, right? This isn't a generic LLM. This is designed and trained every day by our UE Systems experts. It is built on our 53 years of experience. Every case study that we have has been loaded into this, and if you have a similar case, it will reference a case study. It will say, I have seen this before as per case number 22, and you can go and see what case number 22 is, right? But more importantly, is we told it, and we have trained it to make sure if you do not know, do not assume anything. So if you say, do I have a bearing defect? It might say, I see harmonic peaks, but you have not given me the RPM, so I cannot confirm that. Or you have not given me the bearing number, so I don't know exactly if that's from a bearing or something else, but it likely could be. So it's going to give you a confidence score and a criticality, but it'll always tell you what's missing and what data you need to make a better, more reliable call. And that is embedded in UE Analyzer. What I would challenge you with as you use it, it's always your next question that makes it better, right? The first question you ask is usually not in-depth enough. The more you use it, and you can continue that discussion. So you go and you go back and look at the equipment. This is the bearing number. I got it. Or it is belt driven. Or it's direct coupled. You can go back in and say, you know what? It is direct coupled. Here's a picture. What do you know now? And you can keep that conversation going and going and going. And you can save it. So another 6 months later, when you take data, you can say, remember that? I do. let's continue this conversation, right? That is UE1 Copilot built into Analyzer, changing the way the world diagnoses ultrasound. So with all these new tools we have to look at data, we need to innovate our way to also capture data to get it into these platforms. So often we hear from a route-based, or what we call portable, is access gets in the way. And I think this is the right move. Health and safety, OSHA regulations are restricting us more and more on how we can access our pieces of equipment. To solve that, a number of years ago, we created a RAS sensor, remote access sensor, which extends the sensing capabilities from a hard-to-reach, inaccessible place to an area we can go to, right? We often see the number one missed data collection in route or portable collection is because it was not accessible at that time. The second was it just wasn't operational. And that's a you problem. That's not a me problem. Introducing the RAS TX8. It is a fixed, scheduled ultrasound data collection system. It is designed to work with your existing remote access sensors, RAS sensors that already exist today, and essentially change the switch box you may have out there into a wireless, time-scheduled device, bringing data into your DMS on schedule. It allows us to not just capture an overall decibel reading. It allows us to capture and send the time waveform data so that we can bring that in to UE Analyzer. Why 8 channels? Well, there's a history behind that. It wasn't always 8 channels. It was 4. Convenient enough, a switch box has 8 channels. So directly replace any switch box into automatic data capture with the RAS TX8. Battery powered, completely wireless data capture. So this product sits between our manual route-based data collection, where we're having someone go out and collect data, between an always-on system. An always-on system that is constantly, never stops listening. I want to be clear, the RAS TX is on schedule. You tell it to get data every 8 hours from all 8 channels, it will get data every 8 hours from all 8 channels. If you have pieces of equipment that can change their health in that 8 hours, that product might not be right for you. If you have that critical equipment that might go bump in the night, that might fail between that data collection period, is fixed scheduled is not for you. This is our portfolio of fixed, always on. Always on is truly always listening. It never stops listening. And because of that, it cannot be battery powered, because it's going to listen and capture that ultrasound continuously. Never, ever stops. Some of you might know this product. Some of you might have seen it before, and some of you are probably using it. It's the forecast that was created a number of years ago. It has since gone through an upgrade. It now allows us to 4 channels. Now you see why the RAS TX was originally 4. All right, so it's 4 channels because it's always on, always listening. It is powered through a power supply, but it allows us to have 4 independent channels. Irregardless of what's happening on channel 1, channel 4 can be independent. It also allows us to capture data at all 4 channels at the exact same time. So synchronous data capture down to the second. Why is that important? When a failure happens and it can ripple through your complete asset, your drivetrain, whatever it is, it's important that we capture data at all 4 channels at the exact same time from a diagnostic point of view. So that is what's new with the forecast. is simply a firmware upgrade that allows us to enhance the memory and processing power in that forecast to control all 4 channels independently.
So if we can add innovation to the detection, we can add innovation to the diagnostics, then we want to add innovation to the intervention, the action part. And that's why a few years back we introduced the world's first autonomous condition-based lubrication program. And of course the goal here was, let's take all of the lubrication alerts, all the lubrication schedules out of your reliability program. So instead of working to complete these lubrication PMs on critical equipment, let's automate those. Instead of leveraging the outputs of your vibration program to just trigger people to go back and lubricate, let's automate that. And so what we were able to do with some hardware and software is provide that solution. The software then was to give evidence of all of the claims that we were presenting. So we released this product and have worked hard to solidify and fortify the hardware. And now we're releasing, amidst all of this other innovation today, a new version of OnTrack Hub. OnTrack Hub is an additive software that sits on top of the original hardware software design in order to provide you even deeper intelligence. It's not an upgraded path, there's no migration required. It's simply a control panel view on top of the asset management view that you already have today. So in OnTrack Hub, we take an asset-centric view to see all of the assets you have covered, the bearing points you have covered, and we're monitoring not only the IoT infrastructure that provides these kind of outcomes, but the outcomes themselves. So if you have an automated condition-based lubrication program, you want to monitor the health of that program. How many of my assets are truly autonomously lubricating? How many of them I can still manage time-based in the same software? How many of them do I want to add and implement manual lubrication where needed, where a use case might permit? All of that is now visible from a asset-centric corporate view, so you can get a sense of how this program is performing over time. We can see what category of lubrication our equipment is in, but even more clearly, we can see how our assets are performing when there are faults that lubrication can't solve. So we all know that lubrication is an intervention strategy that is very early stage, and it is a preventative strategy, but it can also be a Band-Aid, right, to fill in the gaps until we need to take that equipment down at a convenient time. And so those faults where we say, we're lubricating, we're getting some benefit, but there is a defect here that lubrication can't solve, we visualize those for you as well. So the action that we can do, we do, and the action that we need additional implementation or intervention on, we present to you. So if we were to zoom in at a specific asset level, we can see quite clearly all of the bearing points associated with this particular asset. We can identify, for example, if we have a fault where we're seeing the velocity increase, but the ultrasound and the RPM is kind of staying normal, we will do some of this diagnosis for you. So if we use our Detect, Diagnose, Act vernacular, we have run through the whole process when it comes to lubrication, but then we restart it for more sophisticated faults. So if we say we've been through this cycle, we've done all that we can, now we've detected more issues, we're going to diagnose them, visible to you in OnTrack Hub, so that you then can implement the right corrective action. So this is an example where we've identified that the fault is not related to lubrication. The lubrication history is there and it's working properly. However, there is a misalignment here, and we ask that you correct that when needed and then remeasure on top of that. So OnTrack Hub is something that we're releasing now that will be available to you as an addition complementary to the OnTrack subscription. As we take Detect, Diagnose, and Act, we've had a number of different innovation offerings in those 3 categories. Let's stitch them all together.
They say the most dangerous people are the quietest. You haven't heard a lot about our innovation from UE Systems. This has been 3, maybe 4 years in the works to get where we are today. So our technology has expanded. We have given you new ways to collect data. The challenge that most of you have given us is the workflow we have given you to capture, to analyze, to work on that ultrasound data did not change at the same rate that our ability to collect that data did. These are common things that our customers have told us. They told us something very, very simple. I want one place to schedule all my routes. I want one place to analyze my data. I want one place to manage my ultrasound data, whether it's the on-track forecast, now the RAS TX8. I want one place. I want one place to bring it all together.
We believe industry should listen differently because the sounds of equipment carry meaning before waste, before downtime, before failure. There is a signal. That signal can reveal loss, friction, leakage, abnormal behavior. And when those signals are understood, they become intelligence. Intelligence that can drive action. But as industry changed, the work became fragmented. More data, more assets, more complexity, too often still disconnected. So we learned to listen, to find the earliest signals, to understand what it means to turn signals into decisions, and to act autonomously at the right time with the right response. Portable inspections, fixed scheduled monitoring, always on systems, powerful on their own, stronger when connected. This is UE1, a connected ultrasound platform built to bring clarity to complexity. UE1 connects ultrasound data, workflows, visibility, analysis, and action into one platform. Across portable, fixed scheduled, and always-on systems. Across reliability, energy efficiency, and operational performance. Detect. Find the earliest signal. Diagnose. Turn signals into decisions. Act. Close the loop autonomously. With UE1, signals gain context. Trends become clearer. And changes become easier to see. And teams understand where to focus next. Turning signal into intelligence, into autonomous action. This is the next chapter in how industry listens to its equipment. This is UE1.
This is UE1. This is designed to replace DMS. This is designed to bring all of our products, all of our solutions into a scalable platform built for you, built for our customers. So it connects all of our products from UltraProbe's Forecast, RAS-TX, the Foresight, and the OnTrack into one platform to build a holistic ultrasound program. The core components, UE Analyzer, the new way to analyze your data, built into the entire platform. Not just Analyzer, is UE1 Copilot, your assistance through your entire ultrasound workflows. Pattern intelligence, what we talked about learning normal and detecting abnormal, and the OnTrack hub that Scott brought us for. All that is integrated into one platform. Built around that platform are a number of workflows about how you connect your data sources, to how you analyze data, to how you schedule and drag and drop and manage your route-based program. That's all embedded into UE1, regardless of the instrument and the way you collect your data. As we enter the age of intelligence, is we have embedded intelligence into UE1. with things like anomaly detection. So with our 950 sensor as part of our on-track, as we have ultrasound and vibration, we are capable of sending over 50 data points: ultrasound, RMS, kurtosis, correct faster, velocity, acceleration, RMS, peak to peaks, all these variables. It is a mountain of data to go through. Our anomaly detection models simply detect what was normal and say, hey, this variable is abnormal, or this ultrasound reading was abnormal, or this is using more lubrication than it has in the past. Something is changing. That is embedded into UE1. Another key feature is our baseline advisor. Baselines within ultrasound are required. Ultrasound is a change over time, right? It's an equation. There's always a denominator. But with our new baseline advisor is we can capture in the historical data no matter how much you have, and it's going to constantly validate you have the right baseline set. And in case you have the on-track, it's not going to use just ultrasound, it's going to use the vibration and your lubrication history to also make sure your baselines are set correctly. And you can set it up to check every day, to check every week, but it'll constantly be looking at your baselines to make sure that based on the data it is seeing, that they are set correctly. This stands out on its own. As the world becomes more insecure with the way data flows, is our customers are asking for more control over your data. It is your data, it is not our data. In fact, at UE Systems, we believe we don't want your data. I want to be able to learn from it and learn and work with you, but I don't want to host that data. There is too much responsibility into me to hold your data, because you might want to hold it for 10 years, you might want to hold it for 3 years. We give you flexible deployment options. You can host it in our cloud, and you are welcome to, and that's probably going to be your quickest way to start with UE1. Just use it in our cloud. But if your system scales and you want to take control over your own program, your own data, is you can put it into your own cloud. You now have control over that. Good luck to you. You get to work with IT. But you can do it. We're not going to be the challenge of saying no. Right? You can do it. You manage the infrastructure. You manage how it works. And for those that aren't allowed to use the cloud, for those of you in regulated industries that you are simply not allowed to have that data leave the premises, you can bring it completely on-premise and put it on a server as well and run it independently. Those three options are very rare in this industry, where the companies go around masquerading as a solution company. They're actually a data company. They want your data and they will use it and they will sell it. We're giving you three options to meet you where you're at in your ultrasound program. UE1, where ultrasound programs become scalable. With all of this, UE1, I hope, is very exciting. I hope you see the roadmap around detecting what is abnormal, around collecting data on a fixed schedule, or for those very critical assets, the one that are always listening. But it's greater than a platform. The sounds equipment make, carry meaning. That is our mission. We are here to change the way that you listen to your equipment. That is our goal and that is our mission. We want to take it one step forward. We want to change the way you listen to your equipment and the way you act upon that meaning. So with that, I personally and the UE System team here understands the value of what it means when you say, I do UE. In fact, and the team here will know it from UE Systems, I still use a manual notebook. I'm trying to go digital. But every new notebook I have, and there's a lot of them, the first page of every notebook I have is reserved for 3 simple words. And I write it every single time. It's I do UE. We at UE Systems are very rare in this industry that we are still a privately held company. and we can do things that serve our customer best, that don't necessarily serve our shareholders, right? And that is the difference. That is I do UE. And my promise and UE Systems' promise to you is, for those of you that still want to be working in 53 years from now, I will not be on this stage, but that next person will start their presentation and end it with I do UE. So with that, what we just talked about is going to be available to demo. We are going to give you access from attending this conference to UE Analyzer the minute you step out that door. You can start using that today. You can start using the Copilot today. As you exit this door to your right, you are going to see your room called Hari's Hangout. Hari is our product leader. He's a little crazy, but he's a really good product leader. He has a whole room dedicated to that innovation. He's not a salesperson. He will go under the hood with you. But throughout this conference, go out that door, make a right, head into Hari's Hangout, where we have working demonstrations and under the hood explanations for everything that we just talked about today. And as you exit, you will see banners that have a QR code. That is going to take you to the UE1 website. And from there, you can start your journey today with the new UE Analyzer and the new Copilot. Thank you all for attending Ultrasound World, and I look forward to the next 2 days together. Thank you.